Good morning, and welcome to another episode of the, basically training daily with Khanacademy. Refreshing my entire mathematical understanding uh, from basic arithmetic to algebra to calculus and beyond. And today we have dividing positive and negative fractions. If you have been working with me, for the past couple of months, you would know that I've been trying to um, build a understanding of different concepts to just refresh my memory and to make doing more, I guess, higher levels of math easier. And one of the things that I'd like to do is try to present this stuff in the public eye. So let's go ahead and get started. So first we're going to basically do is going to refresh what the dividing positive and negative fractions are by reviewing a hint. Okay, so here it says that dividing by a fraction is the same as multiplying by a reciprocal of a fraction. If we have 1 over 7 divided by 5 over 2, you basically are doing the reciprocal, which is 5 over 2. So we flip 5 over 2 by 2 over 5, and then you have 1 over 7. It would be nice to know one day why does this work. So basically what we're doing is that we're going to flip it, and then we're going to multiply across, and then you have 2 over 35. So let's go ahead and make sure we understand that particular process. So we have 1 over 7 divided by 5 over 2. We flip the dividend. We flip go to this, and then we just solve, like normal. We have 1 times 2 is 2, and 7 times 5 is 35. And you basically have 235. Okay. Now we move on to the next one. So we have the next one is evaluate and simplify the following complex fraction. And it says here negative 5 over 2. And then it says here 6 is 7. So this is basically what we've seen before. Like that, we're just looking at it in a different way. So then what we do is we go ahead and we focus on doing a reciprocal. We flip these. So we're going to flip it, we're going to say 7 over 6. And we're going to say negative 5 over 2. And then we're going to try to solve, the 0, negative 2, negative 6 is negative 12. Negative 5, negative 4 is negative 5. And I think that would be something good. I think now we have to simplify, right? So since we know that 6 goes into, we do know that 5 goes into 35 7 times, and then 4 goes into 12 3 times, or 6 goes into 12 2 times. So what I'm going to do is I'm going to put in negative 12, 35, 12. Now we know we have to simplify. What do we do with this? How do we do? We got to simplify this one. Simplifying would require me to, if I divide this by 5, we get 7. And we divide it by 4, and we get 3. Let me see if that works. Because there's no one number that you could divide it in both of them. So I guess 7. Okay, so that's not working. So what is it? I flipped that. Yeah, that makes sense. I did that. We get 3512. Yeah. And then we have to simplify. Okay, so what they did here is simplify means 30 positive. How do you get the positive? Because negative times positive would be a negative. Negative times positive is a negative. Negative times positive is a negative. And you have 35, 12. Or 2, 12, 11, 12. What does that mean? I mean, all right. So I guess what they're doing is for some reason it goes to. So we got to figure out that, why does the actual number, how do we lose the subtraction? Just like all of a sudden. That's what I think I would want to pay attention to. Anyway, let's move to the next one. And we have here 4 divided by 5, and then you have 4 fifths, and then you have here 2/9. And then remember our PEMDAS rule, remember PEMDAS. And PEMDAS is we have parentheses, exponents, multiplication, division, addition, and subtraction. And we would want to. Now I know that when we have a multiplication, you can't do. It doesn't really work that way. Like the negative positive functions, the positive numbers don't work that way. So what we would have to do here is that we would have to first think about this thing the same way we thought about before, where we take the multiplication. We have the 4 fifths here. We're gonna flip this. Just flipping it, do we lose the plus sign? I'm not sure, but let's try it out. 9 times 4 is 36. 5 times 2 is 10, right? And you say 3610. You have a negative in here, so it's going to be negative 3610. Okay, so that doesn't work. Oh, I think I put. Okay, that doesn't work. 6. So let's look at this again. Negative 92, 92. The reciprocal 92, yeah, okay, that makes sense. That's I did that right. And this here 4 fifths divided by negative 2 is equal to 4 fifths 92. Yeah, that's what I did. Yeah, that's what I did. And it says here 4 times negative 9, right? Which would give us, oh, really? So it looks like when you have the negative 9 here, the negative 9 gets on the top, but the 2 doesn't get it. You get 3610. Okay. Okay, so what's going on is that I'm putting a negative at the bottom when I should just put the whole thing should be negative, which makes sense. All right, so now we can simplify it, and that would be 18.5, right? And we have the next one here, where it says write your answer in simplest form. So first we do this. So we remember the appendix rule. We change the division into multiplication. Then we change division into multiplication. Then we do then we do reciprocal. I don't know why I was like, yeah. So let's first do this, and then we do this. Then we do this. Then we can go ahead, we can do the multiplication. And then we check to see if we can simplify. So you have multiply, then simplify if possible. First, I'm going to put this in. I think that this is, I don't think we can go any lower than that. Yeah, so that's basically it. All right, so now we understand what dividing positive and negative fractions are. So now we can go ahead and we can do a quick run through with this, what we learned. Order of operations. Convert to multiplication. And then we reciprocal. This one. Two. Then you have convert to reciprocal, and then you have multiply. So 6, you have 10, and we do simplify if possible. You can simplify this, I'm sure. You could use 2, right? It'd be 3/5. The next one. Okay, run the function, appendix. And then you run convert division to multiplication. So it comes like this. Then we do reciprocal of this. Comes 3/4. Then after we come reciprocal 3/4, multiply. And we simplify. Looking at this number here, you can't simplify by divide by 2. We can't simplify by, well, we could divide by 3 here, but this one probably wouldn't work because there's no 3 numbers. 2 times 3 won't work. 4 times 3 is 12. 5 times 3 is 15. We also have 4, which 4 wouldn't work for this. That still wouldn't give us that. 5 would work for here, but 5 wouldn't work for this one. 6 won't work either. So 15/16 is probably the lowest form. All right. Okay. So now we go ahead and we bring up and this. So this is basically, this looks exactly like we did before. It's just that the it's just written differently. So let's write it the way that we remember how it's written. So we're going to do -7 like this, divided by, now, I don't know why they do that. I don't remember what happened last time with this last function I was doing. But we're going to go ahead and we're going to do what we do before. We're going to convert the verse to this. And then we're going to simplify. We're going to, not really, we're going to simplify this. Do the reciprocal. Which that becomes 9/4. And then it's -18. And you have CS7, 7, 18, 14, 2. And then we do that. We're going to take this number and we're going to see if we can simplify this. Well, after we multiply, forgot, let me write that. I'm sorry. We multiply. And then we simplify this. If we find, now looking at it simply, so simplify, I'm looking at the number 4 or 6, because I know 6 goes into 18 3 times, and I know 6 goes into 32, I think 7 times. Yeah. So it would be, and then we would have a negative here because this whole thing's negative. So first, let's go ahead and plug in the negative 18 over 32. And it's going to say simplify. No, it doesn't. I think that there actually was an issue with the. That doesn't make any sense. 18, 19. Did they both negative then? Okay, so it gives help. Let me see. A fraction more means divided by. Did I not multiply that right? Oh my God. I've been doing it the wrong way. Whoops. My multiplication was wrong. Thank you. So we gotta go all the way back. So now we have that. Now we could look at this number again. Can't even simplify, but this was right, but the multiplication was wrong. So we have -18, -28, and then we could do, let me see, what numbers can we use? I think you can still only use 6, but there's no number really that could, let's plug in that and see what happens. Okay. I messed up the number. My whole flow's on off now. Oh, so 18 on the top, 20 -2 on the bottom. Okay, so that's interesting. I don't necessarily know. So when I see this, when we see this, sometimes you're gonna have some gonna be negative somewhere, some of it's not gonna be negative. I'm not sure exactly what's going on. I do know that this is a part of a number. I don't know how the top can be, I don't know how the top can be positive and the bottom can't be. That's kind of interesting to me, but I have to find out. Um, yeah, I was going to simplify this. So we could just 9, 14. I should have taken a picture of that. Okay. So write your number in the simplest form. So it says here 2 divided by 3, 2, 7. And we make sure we pay attention to PEMDAS, where this is going to be converting to multiplication. And then we can do this reciprocal. Then we can do I'm going to say the whole thing is still negative. So we multiply. And then after you multiply, we will simplify. So we have this one would be 7. Did put 2 here, it would be 3. Okay, so I'm going to go ahead and see first if my math is right. This should trigger the fact that it's right, but it should be simplified even more. Correct. And then this 14 divided by 7. And that's great. All right. So that's basically that. You know, it looks like dividing wasn't so bad as it was before, but you know, I think that's all we have today. Thanks a lot. The idea I have to pay attention to remembering is when you do the reciprocal of the numbers, when you have like when we're dividing, let me see if I can actually open that up. Let me put my math homework. I'm gonna go to a new free form page. Okay, so when we have like -2 over -3 divided by 4 divided by -7, what is actually this equaling? You know, we know that this kind of means something like this is equal to well, let's use a number. Let's use a number that is and divide simply into something that we can learn a little bit more about. So we have here, if we have 1/2 divided by 1/2, right? So if we have this, we have a square here, and we divide it into half, and one is 1/2, and the other one is 1/2. You know, we want to know how many times this 1/2 goes into 1/2. Well, in my calculator. Looking at the calculator, I'm just going to tell it gets in. It's just 1 time. So this is very similar. So looking at this, even though this looks complex to me, this is pretty much saying the same thing as 1 goes into 1 time, 2 goes into 2 1 time, 3 goes into 3 1 time, 1/2 goes into 1/2 1 time. You also can do, so that's one thing. So now we can look at a more complex version of this where it says, so with that being said, let's go ahead and let's do 4/2. Oh no, is it 4 7 divided by 7 3, and then 4/2 7 3, and let me see. We're gonna do this. We're gonna use our appendix. We're gonna convert this to 10, and then we're going to and then we're gonna multiply. Oh no, we're gonna do reciprocal. So we'll get that, and then we'll multiply, which will get negative times 7 5 is 49. Negative 7 times negative 7 is 49. Negative 4 times 3 is negative 12. And then we see we have a negative 1249, right? And this would kind of, once we do that, let me see. Um, 1249. Yeah, I think that what happens is that one of these numbers yeah, I feel like that's weird. I don't know why I did that wrong. Anyway, I'm not going to go ahead and put too much time into it. Thanks a lot. I'll figure out what is actually going on by hand. This is something I would always do with calculator, and I'm trying to avoid doing that. So I'll talk to you guys in the next video.